Hi, thank you. So today I'm talking about Lustre 2.5 and beyond. As with anything, this is speculative, and I just wanted to take a minute at the beginning to discuss about the process by which features are landing into Lustre, and there's continual stream of different developments ongoing, and we need to, as our user base grows and the requirements of testing and things like that are increasing with Lustre. It's never an easy product to test. I think we've gotten a bit more rigorous with our feature submission process. If people recount days of yore, we would have a feature, written in a week, and then it would go into production, as soon as it compiled or something like that. And, those days are gone. So now we actually have, for major features, we have a 3-month cutoff in advance. So there's, as Peter mentioned, we have a 6-month cycle between the feature releases. And so halfway through that cycle, we expect that, the first 3 months is open for, patch and feature landings. And then 3 months before the release is when we cut off the features. And, it's not just a matter of people submitting, patches and then it can be landed. We have to understand what those features are doing and how to test them and things like that. And so, the bar is hopefully being raised continually in terms of documentation and design, test plans, and I just wanted to emphasize that for those people developing features, the 3-month cutoff is for the features to be landed. So starting your feature submission well in advance of that gives everybody time to go through the patches, because 2.4, it was pointed out that 2.4 is a very big release, and there was a lot of code and features going into there. But even in hopefully the smaller 2.5 and 2.6 releases, there's issues with integration between patches as well. And so what might have tested in isolation, fine, there may be other interactions with other features coming in. And so 2 months before the release, we want to get documentation and the feature testing plans completed. And so documentation is kind of a new, unfortunately, kind of a new requirement for features. So there's if people aren't aware, there's a Lustre project, LUG, for tracking feature updates, and there's a Git repo, for updating the documentation, and Richard Henwood has a presentation on Lustre, the Lustre manual, and how to contribute. And T-1 month, which is the area we're in right now, we're only landing bug fixes and working on just blockers to get the release, stable and out the door. And this is definitely an improvement over past years, but I think it's really contributed to the stability on an ongoing basis. And of course, the features I'm listing here are, I don't know why that's why, speculative, and they're not for sure going to be in any release, but I've put in numbers beside the release to give you an estimate of when they're coming out. And you can see at the bottom the URL for features, and if you're thinking of working on something, it always makes sense to contact the mailing lists and to look at the wiki here to see what other people are working on, so you don't necessarily duplicate effort. And there's some features that are already being discussed in other presentations, so I'm not really going to cover them here. I'm only going to be talking about new features that are not otherwise having presentations at this LUG. So distributed namespace is an ongoing project to do horizontal scaling of the metadata servers. We had phase 1, went into Lustre 2.4, and that was really a culmination of 6 or 7 years of effort, starting with the clustered metadata project. That was like 2005 maybe, and we're moving forward with the phase 2 of DNE, which is giving striped directories and more improvements to the tools and usage. Lustre file system check, again another OpenSFS project. We've had phases 1 and 1.5 are landed in Lustre 2.3 and 2.4. 2.5 and 2.6 will see further checking for distributed. The earlier phases were local checking to the metadata server. The later phases are checking of the distributed consistency, and if anybody's ever used the existing LFS check tool, you'll be happy to see that this one is being developed. Deos is exascale I/O infrastructure, and Eric Barton is giving a presentation on that. And Fujitsu has a number of different features that are started to land in Lustre 2.4 and will be going on as, I don't know how long it'll take, but they have a number of other features going in. So one interesting feature that is sort of not a feature in itself, but has come about through work that CEA has done for HSM. They did a lot of work to get the layout lock and object data versioning ready for HSM, and the development turned out in the last month or so to allow us to do data migration between OSTs, which is sort of an early glimpse at how to allow storage tiering and things like that. The 2.4 functionality is very basic at this point. It allows you to move one file from one OST. Well, even simpler, it essentially just allows you to swap the layouts between two files. And what you can do is copy a file to a new file that resides on some other set of OSTs. You swap the layouts, which means that the objects from the first file are switched with the objects of the second file, and now you've migrated, and you delete the old data and you've migrated. And so this is a very cool functionality that's wasn't touted as a feature by itself, but the LFS migrate command is definitely usable. It doesn't really do anything by itself. It doesn't do automated storage tiering or anything, load balancing, but definitely the functionality is there to be exploited in the future by like Robinhood or something like that. To say, oh, this OST is full, I'm going to balance rather than pushing it off to the archive or something like that. Or you can have, your SSDs and your HDDs and your, MAID storage or whatever it is. And I think it opens up a whole world of possibilities. So, people can start playing with that. And, I look forward to seeing interesting things that people are doing in the future. HSM, of course, as Peter had mentioned, is a really major feature, and it's been also in progress for a while. So there's a very simple and a useful infrastructure for integrating with different types of back-end storage archives. And the good news about it is there's not really much mechanics inside of Lustre for integrating with the back-end archives. It's all in user space, a copy tool, that has a simple API. It gets commands, and then it's up to the copy tool to decide how to transfer data over to the back-end archive. So there's initially HPSS and POSIX. I've heard a number of times that other organizations are developing copy tools for their archive solution. You know, I look forward to announcements on that as well. So this uses, HSM uses a Robinhood policy engine that CEA also developed, and really that's the smarts behind HSM, and you know, it decides what files to keep, what files to, you know, push to archive, when to release them. You know, it has a sophisticated language for specifying trees and users and, you know, file name extensions, whatever you want. And that's, again, in user space, so Lustre doesn't need the complexity of understanding everything, and it can be, you know, made as sophisticated as we want. And so for 2.4, largely the client-side changes have landed, which, again, you know, like I mentioned, that gives us even the ability to just do simple file migration between OSTs. The server-side changes are under development, and you know, you know, I don't know, apology is the right word, but the unfortunate thing is that HSM, the code has been ready for a while. It had a lot of conflict with the some other work that was being done for ZFS, and so Peter had said that the code wasn't quite ready, but in truth, there's a bunch of conflicts, and it had to be reworked for the new server stack. And so, you know, it was close to making it in, but despite, you know, major efforts from CEA, the code didn't get landed. And but I look forward to this going into 2.5. And as I mentioned, you know, this is going to provide a really useful infrastructure for all kinds of cool features that, you know, are interesting to users, data migration, replication, you know, storage tiers and pools, OST pools, and so I think that'll be a powerful functionality. So another interesting feature that's fairly close on the horizon is the client extended attribute cache. So as you know, kernels and file systems progress, the user applications also are using a lot more of extended attributes. If you have SE Linux enabled, there's all kinds of security tagging, there's search engine tools that use extended attributes, and currently Lustre fetches extended attributes from the server every single time they're accessed. And really, if you're running, or Samba is a major user of extended attributes. So this will provide a very good improvement on the performance on the clients to cache the extended attributes, not only a positive cache to say, you know, I have this extended attribute, but also, especially for SE Linux and other labeling type technologies, they, you know, check on every single access whether there's, you know, a security tag, and you can also cache the negative aspect so that that extended attribute doesn't exist, and you know, that'll save you a lot of RPCs, and I look forward to that one. Client updates. This is really an area I think that has benefited immensely from community involvement. On the other slides, I listed at the top the contributor of the feature, but this one is actually too long a list to fit into the title. You know, EMC, Oak Ridge, SUSE, Livermore, Intel, NRL. You know, really there's a lot of people that are interested in keeping Lustre up to date with the latest client kernels. There's a lot more work going into updating the server kernels. It's obviously, you know, it's an ongoing treadmill, and in the past, you know, at Wham Cloud and Sun, and you know, back to days of yore, we only really followed the vendor releases because that's what the majority of our customers were using. But you know, it's getting easier to you know, build Lustre on newer kernels, and that you know, it takes an ongoing effort, because if you know the kernel development. They don't give a whit about compatibility inside the kernel, and so there's a constant churn of APIs and work that needs to be done to keep Lustre working. There's of course an interest in getting Lustre into the kernel proper. The bad news is that there was 10 years of work that needs to be cleaned up, and yeah, it's definitely going forward, and that's thanks to EMC. So the codes, there's coding style. There's a lot of the wrapper portability wrappers that were added for Solaris and Windows and Mac OS. But the unfortunate thing is that work has resulted in added complexity in the client code and performance issues, and it's not really providing any benefit. And so we've been working on cleaning up the wrappers so that the portable API for Lustre is the Linux kernel API, and the other ones, are implementing a Linux kernel-like library, essentially. libcfs is now going to be like a Linux kernel library so that the main code can be clean. There's some, an open discussion on whether we should just delete the support for the other platforms entirely, because to be honest, I don't think any of them have been compiled in several years, and so they really don't provide us any benefit. Also undergoing, in order to facilitate the client integration with the kernel, is to separate client and server functionality. That is good just from a normal point of view as well, because you're not dragging in a bunch of code that's dead into the client kernel. From the days when Lustre or Linux 2.4, or when we first started developing Lustre, we've been using all these old APIs, and we only reluctantly moved to the newer kernel APIs as the old ones get removed out of the kernel. But there's a lot of new functionality there that we duplicate inside Lustre and could be cleaned up, and so there's definitely an interest in doing that. Dead code removal. There's a couple of projects with Coverity and Clang to clean up this, dead code in Lustre. It's a big code base. I think there's, if my memory serves me, there's over 250,000 lines in the main Lustre code. So that's a lot, as much as all of the other file systems in the kernel put together. And Livermore has been working on the build system cleanup, which is long overdue. It's something that hardly anybody understands, and I'm grateful for that. Indiana has started a new project, two projects that I'll describe. Shared key crypto, which simplifies the ability to authenticate and encrypt the traffic between clients and servers. And there's existing functionality in Kerberos, which is mostly working, but we don't really have anybody who understands it, so we don't really test it on an ongoing basis, and there hasn't been really an adopter in the community that steps forward to submit patches. Indiana is going to be doing shared key in cryptography, which leaves the distribution of the keys themselves as out of band of Lustre. It's your carrier pigeon or USB key or whatever that you transport to some other site to have your crypto key. But then it's very simple to administer. They have the client and the server agree on a key, and they encrypt and authenticate with each other, and then you're done. There's not a Kerberos infrastructure. There's not cross-realm complexity, and you can have arbitrary numbers of keys, and describing which clients have which keys is fairly straightforward. And I think initially it's going to have AES 128, but we'll be flexible. And this actually ties in with another Indiana feature, which is UID mapping, so that separately administered remote domains with conflicting UID spaces can work transparently with Lustre. And in conjunction with the shared key crypto, you can positively identify that clients are coming from the right site, so they can't spoof, you know, their UID maps and access files that aren't belonging to them. And you know, the local IDs, the remapping is handled, you know, of course, only on the server side, so, you know, otherwise it would be totally useless. That gives you the, you know, ability. It's not baked into the original RFP that's being funded by OpenSFS, but this is also very close to being able to give you the two combined to give you essentially virtual subsets of the Lustre file system. So for cloud or something like that, you could potentially partition your global file system into chunks by consumer, and they would be isolated from each other. It's not quite there. There needs to be a little bit of extra work beyond this, but it's definitely a good foundation for going into something like that if that's of interest to users. So there's a number of features that that we're proposing to work on for upcoming releases. One of them, which I think is really one of the most important features that Lustre is lacking today, is file replication. And this is the ability to mirror files across multiple OSTs. And really, for a number of years now, you know, Lustre is been only as reliable as the hardware that it runs on. And, you know, generally, you know, it will be, Lustre will run fine until there's a storage hiccup or a network hiccup and things like this. The networking part of things would be addressed by, you know, channel bonding. The storage side of things is being addressed by file replication. And this also allows you to move into more commodity storage. You don't have to have twin-tailed failover storage, because that functionality would be handled at the Lustre level. And so it's addressing the redundancy, and also for performance. You know, you have 50,000 clients. They all want to read some, you know, 1 megabyte input file. You know, you can replicate your input file onto all of your OSTs and get much better read performance. You know, my preference for feature development is that we get useful functionality at every stage of the game, and the first phase is read-only replication, which sounds kind of funky, because how can you have a replica if you didn't ever write it? But what this is essentially leveraging the same functionality as file migration to allow you to have a copy of the file made in user space, and the only functionality that goes into the kernel to create the replica is like a I/O control to join the two files together, and then you have 2 or more copies of the file, and you implement on the client side the ability to read, you know, any of the replicas, and it's largely for immutable, you know, or very rarely changing files. But you know, for a number of workloads, Hadoop and things like that that don't ever let you modify the files after they're created, you know, this is perfectly acceptable. And you know, for HPC, you definitely don't want to triple mirror your, you know, 50 petabyte file system. But if you want to mirror some selective set of input files for your job that's waiting, you know, a week in the input queue to get an allocation, that's a very important thing, right, for reliability. Phase 2 will be, will have write support inside the kernel, so you would get immediate mirroring of your files. And of course, actually a benefit of the phase 1 work is that you can create the replica asynchronously, I shouldn't say the word asynchronously, sometime after the fact, right? But it doesn't have to use the main bandwidth of the clients. It can be happening on dedicated nodes. It can be happening very close to the OSTs, so that, you know, in HPC, again, your primary limitation is the right bandwidth when you're doing your checkpoints or your data dumps and things like that. You want to minimize that, 5 minutes an hour is the guideline. And so in phase 1, you would be able to do the replication at some other time. And phase 2, it gives you immediate replicas, but it will require twice the bandwidth from the clients. And so, for better or worse, it will give you, your immediate replication. Phase 3, is an extension in terms of doing the replication asynchronously, but it has a very complicated model for recovering and making sure the mirrors are consistent. And so that's going to probably need some of the infrastructure being developed for the exascale work. And, I'm not sure exactly when, I said 2.7, but, we'll have to see how those two projects line up. T10 PI is also T10 diff, as it's also known as. This is work being done by Xyratex, and so it's a SCSI standard for tracking end-to-end data integrity. It's implemented in the Linux client. It's also implemented in disk storage, and it gives you the ability to ensure that the data you write to disk is the data that the application submitted. Speed up a little bit here. Small files on the metadata target. For files less than a megabyte, you get a fair amount of overhead in Lustre. You have a metadata inode, you have an OST inode, you have separate RPCs to access those things. A proposal that we put forward is to be able to store small files on the high IOPS storage of the MDT, which gives you both a better disk IO profile, but also reduced overhead. You could even, we have stat ahead in Lustre 2.3, so we fetch the inode attributes as you're doing like a directory traversal. You could also fetch the data in the same RPC and populate your cache pretty efficiently even across small files, which is interesting. With the ZFS work that was done for 2.4, that opens up the ability to have other backing storage, and unfortunately there's a bit of a stigma around ZFS, despite the fact that I think it's awesome and everybody should use it. But there's some people, we're looking for other backend storage. ButterFS is still more of a investigation phase, just because of we're not sure that it's actually going to scale to what people need. It's primarily targeted at desktop single server kind of workloads with a handful of disks, and we're not sure whether it's really going to scale. But with the advanced features, snapshots, and things like that, there's also going to be a need for integrating that at the Lustre level to have coordinated snapshots across your OSTs and MDT, and being able to access those snapshots inside the namespace of Lustre. But those are both, work going forward, and that's it. So, this is just a glimpse. There's definitely other features that are out in the world that I don't know about. I hope that if people are working on things, they communicate early and often to the mailing lists, and let's make Lustre great. Any questions?
Questions for Andreas? Looks like Galen's got one.
So with some of the other file systems that use like Chord as an underlying placement strategy, you can augment it to be rack aware when you're doing like asynchronous replication, right? To do like,
yep.
Whether you're doing parity declustering or whether you're doing just true replication. Have you considered, and maybe you touched on this and I was zoning out, have you thought about incorporating maybe some sort of LNet aware layout so that you could incorporate rack awareness or even data center awareness in replication?
For replication, there's not any smarts in Lustre today about that. I mean, my thoughts have been that the bootstrap for getting that kind of smarts would be OST pools, and so those could be configured by the administrator, you know, in any arbitrary manner that they want to say, you know, this pool of disks this pool of OSTs is on one rack and one row, and when I create a replica, I want to pick a different pool, or, you know, exactly this other pool, right? So that you can specify that in any way manually. To have it automated, I know there's work in Deos to be rack and, you know, row and switch and disk tray or whatever aware at the policy engine of Deos, but it will, you know, I haven't thought of a project yet to integrate that, you know, automatically at the Lustre level, right? There's actually, to be honest, there's already in Lustre today, we do like round robin across NIDs, right? And so we do load balance that way. In terms of automatically, you know, doing that for fault domain isolation, it's not there, but eventually.
Actually, how to approach multiple approaches for this are being discussed internally, and Fujitsu also contributed a bit of code that they use for rack awareness, where they actually use the OST index as the position of where the actual OSTs are in the global system, which is one of the ways to do it, I guess, and is kind of an easier one. But for initial implementation of this replication stuff, we decided that the implementation would be simple, and we'll offload all of this into the actual replication tools to decide what's where and how to do it. This way we are much more flexible, and whenever we see how things roll out, we'll kind of might to implement it in a more rigid manner in the kernel itself.
Andreas, you appended on a couple of those slides the note Intel proposal. Is that a proposal into OpenSFS? Kind of pending on funding then?
Partly, yes. I mean, I just making a caveat that I don't know we're going to develop them for sure, but you know, there's definitely have done some groundwork in these areas. It's not like these are pie in the sky, you know, I wish we had done these things, but these are, you know, real projects, and yes, we've submitted them to OpenSFS as features developed.
And then kind of on a similar line, the migration work, the data migration work, was that from you or CEA that was, and is that an actual plan or a thought at this point?
So the LFS migrate is actually in 2.4, right? It actually works today.
Oh.
And so the usage of that, I mean, the reason it says 2.4 and 2.5 is that sort of the productization of this is still needed. I mean, it's a command and it has a syntax, but it's not really described as a feature of, you know, how you use it and what you can do with it. It's just happened to be actually almost like part of how we're testing layout lock and layout swap for HSM, but I think it deserves calling out because it's so potentially so powerful, but there's still work to be done in terms of it needs you know, documentation in the manual and something to drive it to actually be useful in real world.
Okay, it's 10 o'clock. We're going to have to stop.
Yeah.
Let's hear it for Andreas. I'm sorry?
One question.
Okay, one more.
Andreas, as I see in your presentation, you present a shared security for Lustre. But what is different with Kerberos in case we will send one ticket to the one host? So as I see no differences between Kerberos, which sent one Kerberos ticket to hosts and to this.
So, I mean, part of the difference is that you have to have Kerberos running, and there's an administrative hurdle, especially if you're doing it in WAN, in order to get, you know, the security infrastructure to open up, you know, cross-realm authentication between domains and things like this. And, you know, to be honest, I'm not a Kerberos expert, and unfortunately, I think there's really not that many people that understand Kerberos because, you know, nobody at Intel does. So, well, no, sorry, that's not at Intel. In our group, there's definitely people at Intel that understand, and actually we have one of our Intel security people looking over the design of this, but it's just administratively a lot easier to say, here's a file with the keys, or here's the 20-digit key, right? But, you know, it's not my area. I'm just... Yeah. Yeah. You know, to be honest, I'm just the messenger here.
Andreas,
so.
can I just come in a minute? The reason that there is a new security mechanism here is because of administration. When you're doing,
Okay, so
when you're doing security across a WAN, it's about, with Kerberos, you're basically throwing open trust to remote sites without much control over it. And this gives the system administrator of the site that is exporting WAN capability much finer grained control over who he trusts and who he doesn't.
Yeah, so I mean, and I'm, you know, don't discuss this with me. What you should do if you have some concerns about this, it would make sense to join the working group, and then you can discuss them there, because I, you know, am not the expert in this. So thank you.
Andreas,